Hello again. This is the second part of the experiments related to figuring out what happens with water using sensors. In this case, there is an ultrasound sensor that we are interested in because, as I said before, the water level sensor gets corroded and will give faulty result after some time. So the good thing about the ultrasound sensor is that it's not in contact with water. It will send a sound wave, and then the sound wave will be reflected by a given surface, and the time that it takes to reach the receiver portion of the ultrasound sensor. First of all, we divide things by two because we are interested only in the reflection. So that means when it goes and then comes back, that's twice the time. And then also we are interested in the speed of sound. So by looking at the time and knowing what the speed of sound, then we will be able to find the distance. So in this case, we have a trigger pin where we transmit a pulse to be reflected, and the echo or the reflection will be received by the echo pin from the ultrasound sensor, which in this case has been connected to pin number 10, the digital pin from the microcontroller. So we are interested in measuring the duration, and from it we're going to be looking at the distance. In this experiment, just for fun, I just assumed that a container is has a height of 10 inches. Obviously, everything is going to be in inches in this case in terms of the distance, and therefore the size of the container. And I decided in this case also that I will say that the container is full when container -8 is reached or below that number. So in this case, 10 minus 8 is 2. That means every time the reading will read a distance less than 2 inches, we're going to say that the water level has been reached, and therefore the container is full, and we stop the flow of water. So again, we decided that the trigger pin is an output. The echo to be read has to be an input, and of course we are going to set up the pulse, right? We wait 2 milliseconds, and then we send one. In this case, it's microseconds, and 2 microseconds. Then the pulse duration is 10 microseconds. Then we turn it low again. So from low to high to low, right? With that kind of duration, and then we expect to read the return, right? The return. So it's all in microseconds in here, right? So it's not like delay. Delay was in milliseconds, but in this case, in microsecond, the numbers are in microseconds here. So again, we read the duration through this function from the library of the ultrasound sensor. Then we convert the duration through this expression. Again, you see divide by 2 because it's the wave has to go to the obstacle, then come back, gets reflected, and then we measure it in terms of distance in inches, right, instead of meters. And you know that the speed of sound is about 334 meters per second in normal temperature. And so again, through the CR printer, we print the distance in inches, and also the message water level reach will be reached when the distance is less than 2 inches, right? And then of course we go back and do the same thing over and over every second in this case. So if we do perform the experiment, here you see the numbers, because I put a box here, as you see this box here in front of the ultrasound sensor. Let me see here if I can extend the camera to give me, yes. All right, so in this case, as you see the box here, obviously it's not very visible. Let me see if I can push this and we can get the box closer. And so in this case, so the box was just an idea that to say like that's an obstacle, and in here it reads about 2.76 inches. Again, the variations are the fact that you have to be very careful on how to set up the angle of the ultrasound sensor, because the reflection, if it's not incident, so some of it can or maybe some energy can be reflected in other directions, and therefore it will have faulty readings. So we want to make sure, like it's in a rigid environment, and the angle has to be incident to the obstacle as much as you can, right? But again, we're trying to figure out that, or we see that usually the accuracy is better when the obstacle is closer to the ultrasound sensor. In this case, it says about 6 inches. So if I measure it approximately, it's about 6 inches. Wow. Well, and there it says less than 6 inches, but it looks like it's about 6 inches or so, right? About, or a little bit less. So, okay. So it's not that bad, right? I mean, the sensor has usually good characteristics in terms of accuracy. But what I'm interested in is dumping this in a cup of water. Not dumping it, but setting it up. And as much as possible, if it were perpendicular to the water, it would be even better. And as you see here, the amount of water that I have gives me about that much distance, right? Of course, in your case, when you deal with this experiment, you're supposed to add water as you go and check that the water level that is red is going to be having or related to a distance that is very large when the cup is empty. And as you add water, the distance becomes smaller, and then depending on what you consider to be full, you compare to that number. In this case, I used 2 inches, but you can use less than that, more than that. It's up to you. You just don't want the water to touch the ultrasound sensor anyway. But again, if you had the rigid place for the sensor to be located, it would be even better. But otherwise, it is not a bad experiment for figuring out a good application and a good and a solid way of looking into how to measure the level of water, and which can make lead to applications where if you want to fill a container when it's empty, like they do in the refrigerators, or like in our refrigerator, for example, you put the container into a portion of the fridge, and then it fills itself, right? And then when you go back, you will see that it has filled itself to a specific level, and it stops, right? It stops the water flow. So have fun making it to the way the experiment has been designed, and enjoy it.